S-R Latch using NOR gates. Okay. Here, first, whenever we are going to design, what we need to do? Whenever we are going to design a logic circuit, what we need to do? You need to analyze the problem. Correct. Here, what is S and what is R here? S is set, R is reset. S is a set, R is a reset. S means set, R means reset. So what is the representation? Reset. Reset representation is 0. Set representation is 1. Anyway, finally we need to do only 2 bits. Yes or no? Set, reset. Are you following? Are you clear? So, when we are taking any latches, when we are taking any latches, when you're taking any latches of flip-flops, when we are taking any latches of flip-flops using NOR gates, definitely we need to consider R first. We need to consider R first. Next, we need to consider S. Next, we need to consider S. Means, whenever we are going to design a S-R latch using NOR gates, you should take input R first and S next. But when you go with the NAND gate, you should take S and R. Okay? Clear? This you should remember. Procedure is same again. Remaining following procedure is same. Difference between NOR gate and NAND gate. In NOR gate implementation, in S-R, set and reset, blue shirt, stand up. S-R, you should take first reset, then you should take next set. But next onwards, NAND gate, because next onwards we are going to use NAND gate representation latch, and flip-flops also we are going to use NAND gates. Everywhere you need to take S-R, but only in this case we need to take reverse. So remember, if you miss this, complete things are going to miss. Are you here? So first important point, difference. So this is a S-R latch using NOR gate representation block diagram. Just observe, as I told you, 2 inputs, S and R, NOR gates. So this is input. When I am reading input, what is going to happen? Generally, your combination circuit input and output. But here, input, again this is going to be get this next state input output we are considering. Current input, current state. For representing of next state. This is a direct line next state, this is a complement line next state. Are you following? If you wanted to represent QN as output, outcome, input, this is input, right? State line. This is input, right? So, here. This is input, right? Now, current state also we are going to consider as an input. Current state, QA current state we are going to consider. Here, this is a sequential logic circuit S-R latch. using NOR gate. Okay, if you understand this, latches are different clocks. Yes or no? Latches are different clocks. So it's a flip-flop without clock. There is no clock representation. That is why it is a flip-flop without clock. Maybe flip-flop also representation is same, but clock will be added. That is what. Understand this. Remaining topics are very easy. Clear? Only one clock we are going to add. Next D flip-flop, K flip, every flip-flop, one extra is going to add. This is basic. You should remember and understand this problem properly. Baba Kucho. Now, okay. Now we know this. Now what we need to do? We need to design a truth table. How to design a truth table? What are the inputs are there? What are the inputs are there? Yes, we need to give reverse, but inputs always S-R Latch. Why you are giving inputs reverse? NOR gate we are using. As I told you just now, underline that point. NAND gate you should use same order, S-R only. Are you clear? Remember this. So S-R is input. As I told you in a sequential logic circuit, always output is depending on current input, current state. This is current input maybe. Yes or no? This is a current input, right? SR is a current input. What is a current state? What is a current state? Qn is a current state. Yes or no? Yes or no? Or present state. Current state or present state. Then what is the output you want? What is the output? Q n plus 1. That is a next state. Correct. When you want this next state n plus 1, what is going to happen? What is going to happen? R and input is what? R plus Qn bar whole bar. Yes or no? R plus Qn bar whole bar. Yes or no? Always you should be calculate next state, not current state, because as I told you, the output is depending on current input and current state. So what you are calculating next state. Are you clear? Not current state. Yes or no? Yes or no? Right. Then SR Q0. The possibilities. What is the possibility? 0, 0, 0. Please carefully you follow. 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. Yes or no? Then 1, 1, then just observe 0, 0, 0, 0, 0, 1. Why? Because I am taking again 0, 1, 0, 1, 0, 1. Means it is changing. Means don't care condition. Q0 current state is a don't care condition in this case. Are you following? 1, 0, 1, 0. Yes or no? Both cases we can take 1, 0, 1, 0. Here 1, 1. But this Q0, it is not depending on your SR. Yes or no? Yes or no? So now we need to calculate n plus 1. This calculation we are going to do for every problem. You understand this problem. Every problem, same story, same repetition. So please try to understand, try to work out here, try to learn this. So tell me, what is the first case? S value equals to 0, R value equals to 0. What we need to calculate? We need to find the next state. What is that? Qn plus 1. Correct? What is Qn plus 1? What is Qn plus 1? Tell me. What is the Qn plus 1? R, yes or no? What is the R value here? 0 plus, then one more input is what? What is one more input? Current state. What is that? Qn bar. Yes or no? Then this is a NOR gate. So, total bar. Yes or no? Yes or no? 0 plus something? 0 plus something? That's something only. Then what it is going to come? Qn. Yes or no? Is there any change? Is there any change? Next state is pointing to same current state. Yes or no? Yes or no? Sir, no sir, I am not satisfied with the same direct port. I want to work with complement port. If you are not satisfied with direct port, if you are not satisfied means your output is not satisfied with direct port, please check with the complement port. But here what happens, if I go with complement port, can I get any extra data? Because your S value is 0, R value is 0. Yes or no? Both are same. Don't expect more than that. You do it, you will get same. Unnecessarily don't do that. Are you clear? Are you clear? So, you fix it. This is a QN. Means, what's that? No change. Correct? No change, right? Either you will get 0 in this case or 1. That's why no change. Correct? So, next case. S value is 0, R value is 1. Correct? Yeah. Now tell me. You should calculate next state. Qn plus 1. Yeah. Tell me. What happened here? R value is how much? 1 plus Qn bar whole bar. Correct? Right. Tell me. What is going to happen here? 1 plus Qn bar whole bar. 1 plus something is 1 plus something. 1 only. 1 plus anything, 1. Boolean algebra. You forgot. Yes? Then what is going to happen here? 1 bar. 1 bar is nothing but 0. Now I got some value. No need to check complement port. Direct line I got 0. Yes or no? No need to check the complement. If you are complex, if you are not getting anything, only you go with the complement line. Are you clear? So what is this? 0 means what? Which case? Which condition? Reset condition. Yes or no? 0 means reset, right? Right? Yes. So now this is a reset state. Got it? Then condition 3. What is that? S equals to 1, 0. Now do this. Qn plus 1 equals to 0 plus Qn bar whole bar. Then 0 plus something? Qn. Now there is a scope. Here there is no scope. Why? Your input S equal to R equal to both. S equal to R. But here S is not equal to R. S or no? So we are getting no change, but this straight line. Then you check complement line. What is the complement line? Qn plus 1 bar. What is the Qn plus 1 bar? What is the S value? 1. Are you following? Plus. Then what is this input state? Qn. Whole bar. Now tell me, what is going to happen here? 1 bar equals to 0. With respect to Qn plus complement, what is the Qn plus 1? If Qn plus 1 is 0, with respect, Qn plus 1 is how much? Array or Qn plus 1 complement is 0. Then what is Qn plus 1? Use brain. Yes or no? A bar is 0, A bar is 0, A bar is 0, then A is 1. Same logic. Qn plus 1 bar equals to 0. What is the Qn plus 1? 1. With respect to that, it is 1. So, it is 1. What is this? Set condition. Are you clear? Clear. This problem is very important for learning of sequential logic circuits. Next, fourth case. S equals to 1. Yeah, please check it. Qn plus 1 equals to 1 plus how much? 1 bar equals to 0. But already is there. Then go with the complement. Again 1 plus Qn bar, whole bar, 1 bar, 0. Check. Is there any chance A equals to A complement? Is there any chance A equals to A complement? But this condition is saying same. Qn plus 1 is 0, Qn plus 1 bar is 0. So this is not correct. So this is called indeterminate condition. Indeterminate condition, that is called ID. Indeterminate condition, that is called ID. Are you clear? So we can rewrite, we can rewrite this table, this truth table with considering of all these. Understand 4 conditions? These conditions we are going to use every flip-flop. That is what. So we can rewrite in short way. Next cycle onwards, I don't want to write this much table. I will write very shortcut how to write. Current inputs, current state, and next state as a output. So what is the chances? 0, 0. Yes or no? Yes or no? 0, 1, 1, 0, 1, 1. Then 0, 0, Qn. No change condition. 0, 1, reset condition. 1, 0, set condition. 1, 1, indeterminate condition, ID. So this is a representation for S-R Latch. Clear?